Okay, let's go do number 12. And it says they want us to find the correlation. And the only ways to find the correlation is one, to have the data, or two, to have R squared. Now they don't have a data, so let's see if they have R squared, and they have it right here. So it's 60.9%. So let's write it as 609. And we're going to take the square root of that, and we get 0.8. Now, you're not done yet. Because remember, R squared is always positive, but R can be negative or it can be positive. And so we have to figure this out. So how would I figure this out? Well, the answer is you look at the slope. Because remember, if the slope is positive, R is positive. If the slope is negative, R is negative. So which one of these numbers is the slope? So this is where we look. And we either have a choice of a constant or a noun. Now the constant is always the y-intercept, so it has to be the noun. And do you see how that number is negative? I don't care what the number is, I just care that it's negative. So therefore I know my slope is negative. My R is negative. Okay, B, how many cars included in this analysis? Well, they want to know what N is. Look at that. 89. And it says here, a car you're thinking about make a difference 180 to what's the difference? All right, so hopefully you realize that the equation of the line is going to be, so what is it, a data desk? This is in the size, the displacement engine, between a car's fuel economy and its weight. Okay. Okay, so we got engine sizes. So we got the miles per gallon is equal to 34.9799 plus negative 0.66196, and let's do inches cubed, okay? All right, so this is the equation I'm going to use. This is the equation of a line. So the first one is, the first x is going to be 190. So you notice how I use the whole number? Don't round it. Don't round it. So 34.9799 plus negative 0.66196 times 190. Minus, now I'm going to subtract, and I get 34.9799 minus 0.66196 times 240. Okay, you do the math on that, and you get 3.3 miles per gallon, or miles per hour, whatever it is, okay? Okay, let's go to 13. People always have trouble with this. So what we want to know is the association between the two variables. If it's linear, I want to know if it's positive or negative slope. If it's curved, write C, and if there isn't anything, write N. Okay, the length of a person's hair, and then you say the number of credits that a student earned last year. Hopefully you know that has nothing in common. So that's N. The power strength of a microwave, and then the number of minutes it takes. So hopefully you realize that the higher the power is, the shorter time it takes to boil the water, right? Higher the power, so that would be negative because we're going in two different. This is up, and this is down. Okay, the hours a person has been up past the normal time, and the time that it takes them longer to complete the puzzle, right? So that's positive. The number of days that it rained in a month and the number of times you mowed the lawn that month. Now that one is tough, because the deal is that if it doesn't rain a lot, you're not cutting your lawn a lot. But if it rains too much, you can't cut it at all. So it's a curve. So this is C for a curve. Okay, let's go to the last one of number 13. The number, so what, this was N negative, positive, curve. Okay, the number of days in of 100 degrees in the summer during the week, and the number of sweaters, so the less amount of sweaters, right? So that's negative. All right, so let's go do number 14 here, which is the exemplary variable. Now this is what goes in, okay? And I hope that you realize that it is week. And then they ask for the correlation, so I literally put all those numbers into my graphing calculator. And what did I get? Stat, edit, I'm using the TI 84. And I get negative 0.96. Remember, 2 decimal places. And they want us to know, you want to predict whether or not you will qualify for that raise. Is the linear model appropriate? And I said yes. And why? Because there is no pattern in the residual plot.